So let us consider another question, still on our derivatives, working with the first principles and also the general rule. We are given on question number 8.1, determine the first derivative with respect to x from first principles. If it is given that f of x is equal to minus x squared. So guys, I've already showed you the formula that you are given this from your formula sheet, all right? You have got your first principles formula, the definition of what? Of a derivative. So that is what you're going to need. That's the first derivative with respect to x is going to be limit as h approaches to 0 of f of x plus h minus f of x, everything over h, like this, where f of x is already given. So what we're going to need is f of x plus h, all right? Which I said in place of x, you must substitute that x plus h. So it's minus x squared, minus on its own. The minus is outside. So expand x plus h squared, which we expanded previously. This bracket, guys, we saw that it's going to give us x squared plus 2xh plus h squared. If you expand it properly, then with the negative that is outside of the bracket is going to multiply each and every term. Then that was going to give us negative x squared, negative 2xh, negative h squared. So this is our f of x plus h that we are going to need into our formula. So that's limit as h approaches to 0 of what? F of x plus h, which is minus x squared minus 2xh minus h squared. Then we are going to subtract our f of x. Our f of x is what? Minus x squared. So since we've got a negative, let me just put a bracket here. Minus what? X squared. Everything over h. This is it. That is the whole idea. From there, you can simplify, expand this by the negative that you're given. Nothing is new from this question, guys. So negative times negative was definitely going to give us a positive. So it was going to be minus x squared minus 2xh minus h squared minus minus, that's a positive. So it's positive x squared, everything over h. And this, collecting your like terms, minus x squared plus x squared was going to cancel. This was going to give us what? A 0. Minus 1 plus 1. So that was going to cancel. And you remain with these two terms in between, which is limit h approaches to 0 of minus 2xh minus h squared over h. And that's it. Get rid of the h in the denominator before applying the limit, either by separation minus 2xh over h minus h squared over h, which was going to give us minus 2x minus h. All right. Or you can do this by factoring out the h, which is common in the numerator. And that was going to give us minus 2x minus h squared divided by h is minus h. Everything over h in the denominator. And this allows us to cancel this and this since we've got a product. So our denominator is no longer part of our question since we canceled. So we are left with this limit of what? Minus 2x minus h. Where h is approaching to 0, you put a 0 in place of h. So it's minus 2x minus 0, which is what? Which is minus 2x at the end. So that's our first derivative with respect to x, minus 2x at the end, just like that. Just like that. So we want to prove with our general rule, if this is it, all right, the first derivative with respect to x simply means we are going to drop the power. So that's minus 1 times 2, which is minus 2x to the exponent. We subtract 1 on our power. So 2 minus 1, that's 1. So that's minus 2x. Exactly the answer that we got, minus 2x. Exactly the answer that we obtained from the first principles. So the general rule can also be used in place of that. It is just a simplification, as you can see, but use what you are told to use the first principles, all right? Where you are not told to use the first principles, that is where you can use the general rule, like this part of question 8.2, determine 8.21, the first derivative with respect to x from f of x, which is given as 4x cubed minus 5x squared. All right, so this was easier, guys. We just have to use the general rule, drop the exponent, the power, then subtract 1 as before. Use this. All right, so that is it. Drop the power, subtract 1. So 4 times 3, that was going to give us 12. 4 times 3, that's 12x to the exponent of what? 3 minus 1, that's a 2. All right, so that's the same thing here. You're going to drop the power, then subtract 1. So 2 times 5 is going to give us negative 10. X to the exponent of 2 minus 1, that's 1, which is same as what? X. So you can just leave it like this. You're done. All right, for 2 marks. All right, let's consider another part, 8.22. There we are given to differentiate with respect to x, this whole term, that's right, minus 6, then the cube root of x plus 2, everything over x to the exponent of 4. All right, remember we dealt with something like this from the separation of fractions. When you're given a single term in the denominator, we can separate the numerators, the numerator to the what? To the given denominator. So meaning to say this was going to be this term over this, the first term, was minus 6, the cube root of x over what? X to the exponent of 4 plus 2 over that again, 2 over x to the exponent of 4. All right. As we have if we have separated, we still cannot differentiate since we do not have the form ax to the exponent of n. So we must get rid of these roots, these fractions, 2 over this. All right. So remember the cube root of x this is 1 here that we have, and we have discussed that if it is x to the exponent of what? M over n, it is taken from this. So that cube root of x, it is the same as x to the exponent of 1 over 3. The power is your numerator. The number in the root is your what? Your denominator. So that's to the exponent of 1 over 3. So it was the same as minus 6 x to the exponent of 1 over 3, the cube root. But everything is over x to the exponent of 4. So we're back now to the laws of exponents. Same base, x and x. We are going to subtract our exponent since it's a division. So that's x to the exponent of 1 over 3 minus what? Minus 4. So that's minus 6x to the exponent of what? 1 over 3 minus 4. This was going to give us negative 11 over 3. All right, so that's it. That's what you're going to obtain from this simplification. So that was going to be this minus 6x to the exponent of minus 11 over 3. From this whole part, we have simplified. Then we move on to the second part. That was going to be plus. All right, so this is plus 2 over x to the exponent of 4. Remember, guys, I talked about this when you're given this in the denominator. We're going to take it up with a negative exponent. So that's a positive 4. It's going to be a negative on top. So that's 2x to the exponent of a negative 4. That is the whole idea. It changes the exponent. That is the whole idea of 1 over. So as we have got this format, this is the format on each and every part. We can differentiate because this allows us to drop the exponent, subtract 1 from the derivative part, the basic rule. So you can use this now to differentiate. Drop the power, subtract 1 from there. So let's start our differentiation, guys. Now we are differentiating. So we are not going to write down this dx. We are now having our answer. So drop the power, subtract 1. So that's -6 times -11 over 3, our power. -6 times -11 over 3 is going to give us 22. So that's 22x to the exponent. We subtract 1 on our power. So that's -11 over 3. Then we subtract 1 on our power like this. It's going to be -14 over 3. -14 over 3. So that's our derivative. We have differentiated, drop the power, subtract 1. You're going to obtain 22x to the exponent of -14 over 3. All right, to the exponent of, all right, sorry for that. All right, I think it's a network or something. Okay, let me do this. To the exponent of -14 over 3. All right, so that's it. Then we move on to the second part. Again, the same concept. You're going to drop the power, subtract 1. So if we do this, it's +2 times -4 our power. That's going to be -8. But here we're going to subtract the -1 from our power. -1, -4 is -5. So that was going to give us -8x to the exponent of what? -5, like this. So we have differentiated each part. We have differentiated this by separating our terms. So we have our final answer at the end. So that is how you play around these derivatives using the general rule. So for 11 marks, all right, it's something reasonable, guys. Just do revise as many questions as you can. Just add more questions from this.